All right, so I want to do a screencast of some relevant reactions for the final exam. And what I would like for you to focus on is being able to correlate reactions, reactants, and conditions to certain products. And a lot of these are going to deal with alkene chemistry. So anything that I put on this screencast is something you should really take the time to learn and learn well. And I'm going to use a recurring substrate so that we can talk about stereoselectivity, stereospecificity. And that substrate is going to be 1-methyl cyclopentene. So the first reagent I'd like to discuss is borane BH3 with a THF solvent and in the second part of this mechanism we use hydroxide ion and we use hydrogen peroxide. In fact, it's a really good idea to make note cards, and on the side of the note card without any lines to put your substrate, that's this guy right here, and your reaction conditions, and then on the other side to put the product and maybe list any details about the reaction. So some things we need to know about this reaction. We are going to add H and OH to the carbon-carbon double bond. The OH is what we call anti-Markovnikov. Anti-Markovnikov. The H and the OH add syn. That means on the same side. This first part is called regiochemistry. And the second part is called stereochemistry. So with our particular example, you have one of two possible correct answers. The methyl group could be coming out, which of course means the hydrogen will be going in, which of course means that the OH will be going in. Or the methyl can be going in, which means the hydrogen is coming out, which means the OH is coming out. This is borohydration oxidation. Borohydration oxidation will give us the anti-Markovnikov alcohol with syn addition of the elements of water across a double bond. Now let's look at a closely related reaction, but one that gives us different stereochemistry and different regiochemistry. We call this the oxymercuration demercuration. So we use mercury 2 acetate. And water. And in the second step, we're going to use NaBH4. And again, this is called oxymercuration demercuration. You're going to get a Markovnikov alcohol. Which is, of course, the regiochemistry. And the stereochemistry is scrambled. So it will add both syn and anti. And so the two products that you would get and you really don't even need to show these because they won't be chiral. And of course the second one. And they're not chiral because you can't distinguish between these two carbons or between these two carbons. So this is oxymercuration, demercuration. Okay, next one we want to look at is, Carrie, this is for you, your little chartreuse molecule. Let's look at adding Br2, adding Br2 and H2O, adding ozone, and then reducing with dimethyl sulfide. So when we add bromine, we add anti. And to save a little bit of time, I'm just going to write plus enantiomer. When we add Br2 in water, we add what is called a halohydrin, but the OH will go to the more substituted carbon. And of course, they'll add anti as well. And we'll get the enantiomer just like before. And with ozonolysis, just to remind you, if one draws an exaggerated double bond, we can erase between the double bond, and two of our three oxygen atoms from ozone become incorporated into the molecule, and the third one becomes incorporated to make DMSO, which is our minor product, our non-organic product. And so this has 6 carbons, and we'll have an aldehyde, and we will have a ketone. So all three of those reactions are fairly important. Let's look at some others. Again, same substrate. So let's look at osmium tetroxide and then sodium bisulfite. Let's look at MCPBA. let's look at NBS, BR2, and light. Let's look at H2 with a metal catalyst. Okay, now we're going to go a little purple. Osmium tetroxide will enable us to produce a syn diol. It's a vicinal diol, and both OHs will go in or come out, which means they both add from on top of the double bond, or as I'm showing here, from below the double bond. With MCPBA, we will make an epoxide. With MBS, we will get allylic bromination, and we will get two distinct products because there are two non-equivalent allylic positions. And finally, with hydrogenation, you're just going to convert the carbon-carbon double bond to a carbon-carbon single bond. And remember, the H2 adds syn as well. So these are some of the really high yield reactions that you can expect to see on your final exam. Just off the top of my head, I want to say they may account for as many as 8 to 10 questions on your exam. I would know them really well. I would study them because it will pay off on Wednesday.